Functions are the last type of special equation that we're going to be learning about in this special equations mini unit. And the definition of a function is a relationship that every input has one and only one output. Now, believe it or not, you guys have been talking about a very, very basic definition of a function when you did function machines a long time ago. And this hopefully maybe looks a little familiar, maybe not exactly like this. I know I'm not super artistic, but you guys know that this means, for example, if I put a 1 into the function machine, the rule tells me to add 10, and an 11 would pop out. If you put in a 10, it goes into the function machine, 10 plus 10 the rule tells me to do, and I end up with a 20 that pops out. If I put in a 5, it goes through the function machine, add 10, and I end up with a 15. Now what if I put in another 5, and now 15 didn't pop out, 14 popped out? That wouldn't work. That's not a function anymore. So every input has one output according to the rule. So that's the definition. Now in 8th grade, really you've been doing functions when you've been solving for x or y using an equation. If I put x in, a y can pop out, or I could plug a y in and an x would pop out, and it has to work according to that rule. So for example, if I plugged in 10, if I told you x is 10, we know that I'm going to set up my equation, y equals 2 times 10 plus 3, according to this rule over here. So I'm putting in a 10. I want to see what's going to pop out here using this rule. 2 times 10 is 20, plus 3 is 23. So according to this function rule, when I put in a 10, a 23 pops out. Now what if I put it in going backwards into my machine, and what's going to pop out? What is the input going to be that pops out? So if I do that, I'm going to write out my equation, y equals 2x plus 3, and I need to solve backwards. And we know we're going to do that by subtracting 3 from both sides, and then divide by 2. So you're doing the opposite. You're subtracting and dividing instead of multiplying and adding when you're going the opposite way. And x would be 1. So that's how we've been using functions all year, but we haven't necessarily looked at it using this definition. So today we're going to look at it from an equation, from a graph, from a table or some ordered pairs, and also something new called a mapping diagram. So first, from an equation, we need to have an x and a y, or just a y. Vux equations are not allowed here, and we'll get to the y when we talk about graphs. That'll make a little more sense. So we're going to say no to Vux and yes to the others. So this one's got an x and a y. This is going to be a function. This one just has a y. That's okay. That would be hoy. Special case hoy. Yes, that's a function. This next one, I only have an x. That's going to be a Vux equation. If I moved it around, just as a review, we multiply to get rid of the fraction, multiply by the reciprocal. So x equals 16. Now that's a Vux equation. That's going to be a vertical line when I graph it. That's going to be important in a minute, and you'll remember me saying that. A vertical line is not a function. No. This one, y equals 2x plus 9. Yes, that's a function. It's got a y, it's got an x. We're good to go. So next, from a graph, in order for something to be a function, it needs to pass what's called the vertical line test. And that's something new. If you're following along on the notes, that's going to be your fill in the blank there. A vertical line test says that when I take a vertical line, I'm going to use my marker, and I move it across the graph, it can only touch the line once at any point in time. If it touches twice, it fails the vertical line test. So for this one, if I start on the left-hand side and I move, it never touches the marker more than once. If you needed more of a visual for that, if I draw just a bunch of vertical lines, it doesn't matter where, the line is only hitting each vertical line one time. So yes, this is going to be a function. For this one, this is very clear to see right away. If I start from left to right, already I'm touching 2 times. That's not allowed. That failed the vertical line test. This is not a function. Same with this one. We've got like an S on our graph. right away I can even just look at my y-axis there and use that as a vertical line, and it's touching 3 times. That relationship is touching my vertical line 3 times. This is not a function. It's only allowed to touch once. This one I've got like an oval, and again we can see the vertical line test. It's always vertical. It's touching twice in a bunch of different places there. This is not a function, no. Now if you're following along with the notes, I added 2 extra graphs here for you. This is sometimes confusing for kids. We haven't really looked at graphs like that aren't connected all the way back since scatter plots. So these ones we can look and see if it's a function just based on whether the dots line up to a vertical line or not. So for this one, if I'm starting on the left and I move right, it's touching 1 dot, 1, 1, and 1. So yes, this is a function. Whereas here, when I start, already I have 2 that are lined up vertically on top of each other. This is not a function. So now we're ready to get going on to a table or ordered pairs. Now for a table or ordered pairs, we're going to say repeat x's, exit out. We cannot have a repeat x. X is our input value, and if we have a repeat x with different y's attached to it, that means our machine is broken. Think back to this plus 10 up here. When we put in a 5 and it followed the rule and we got a 15 out, that worked. When we put in another 5, that's another input, another x, and we got 14, that didn't work. It broke the rule. That machine was broken, so it's not a function. So we're going to think back to that. Repeat x's, exit out. Repeat y's are okay. We don't care about those. We can have repeat y's. So here I'm going to look, and I'm just looking at my x column. I have a 1, a 4, a 6, and a 23. There's no particular pattern really going on there. I don't care about a pattern or not. I just care about repeat x's. There are no x's that are repeating. Each one just is shown 1 time. So yes, this is a function. For this one, I'm just looking at my x column. I don't care about the y column, just the x. And when I look down, I've got a 3 that's doubled in my x column. Repeat x's, exit out. Not a function. No. Now tables are just ordered pairs that are organized, so this is the same deal here. We're looking at repeat x's, exit out. So I'm just going to highlight the x's. We don't care about the y's. And if I'm looking, I have a 2, 5, 2, repeat x's, exit out, not a function. For this next one, you may be saying there's a lot of 3's here, which there are, but remember I'm only looking at the x values. So I have -2, 5, +2, 3, and 4. Even though the y values repeat over and over and over again, I don't care about that. I do see already that there's no repeat x's, no repeat x values. So yes, this is a function. Now I just want you to think about this from a visual standpoint and go back to that vertical line test. I'm going to sketch a really rough graph real quick. -2, 3 is going to be about here. 5, 3 is about here. 2, 3, 3, 3, and 4, 3. So that's a super rough graph of this one that we just said is a function. The reason why the y's we don't care about, that's going to be a horizontal line. That's going to end up being hoi. And that would pass the vertical line test. So that's just a visual for you to think about there. Last but not least, we have a mapping diagram. And a mapping diagram is just a way to organize ordered pairs. You can kind of think of it as like a flow chart for a function. Oftentimes it'll say x and y to show you the different, to decipher between x and y. Sometimes it will say input and output. It means the same thing. Essentially it's a list of x's, a list of y's with some lines or arrows connecting them to show which ones go with which. So for this one, to determine whether it's a function or not, I need to see if it's repeating. And some kids are able to see it right away and some kids are not, and that's okay. This -1, I can see in the mapping diagram, is pointing to 3 and 4. So this is not a function, and the reason why, if I wrote these values out, the -1 points to the 3, and the -1 points to the 4. Remember, no repeat x's. They're not allowed for a function. Repeat x's, exit out. This is not a function. And our last example for today is showing another mapping diagram. This one, notice each line from each x value is only pointing to one y value here. So if I listed these values out into ordered pairs, I'm not going to have any repeat x's. So yes, this would be a function. So remember, for function, repeat x's, exit out. Remember, vertical line test. Every input has one output. Think back to when you were little again, to those function machines. Bye, guys.